Okay, good afternoon, people. Today, we want to discuss the most important topic in project planning and management, and the topic that helps many project managers to do their planning very well and execute their duties as stipulated. So today, we want to focus on critical path method. Critical path method is a very important method that enables the project manager and the team to know which areas of the project are very important and which areas of the project can be delayed without affecting the delivery of the project. Thus, we can say CPM is a method used to calculate the critical path and thus identifying the total float of the project. So speaking of the float basically is a free time on the project or the delay that cannot affect the total time estimate of the project, thus allowing project crashing. So the term project crashing basically entails that this project, people can have some free time without affecting the estimated time for delivering the project to the users. So when you crash the project, it simply means that you know, okay, the time that is free before you give the project to the customers. So for example, if you have total free times in the project of 10 days, it means you can deliver this project anytime within 10 days. And that's what you call project crashing. So this is only made possible if you know your critical path and also you're able to calculate the total float of the project, then you can tell when to crash the project, so to speak. All right. So now moving on, the critical path basically is a sequence of activities with the longest duration. A delay in any of these activities will result in the delay for the whole project. So now, why is critical path method important? The critical path method can help you keep your project on track. It can also help you identify the activities that must be completed on time in order to complete the whole project on time. Show you which tasks can be delayed and for how long without impacting the overall project schedule. So calculating the minimum amount of time it will take to complete the task. Additionally, it can also tell you the earliest and the latest dates each activity can start on in order to maintain the schedule. Right? So now let's talk about critical path analysis. As we earlier alluded to, critical path method enables you to do the critical path analysis. So now, how do you do this? So before you do the critical path analysis, you must be able to perform these three things activities, of which the first one, you must be able to develop the WBS, which we know by this time that if you said WBS, we are referring to work breakdown structure. So it's supposed to be the first thing that you need to do before you do the critical path analysis. Then secondly, you need to make easy to handle computations to create the so-called the forward pass and the back pass. So basically three things will be very cardinal for us to do the critical path analysis. All right, of which the first one, come up with the WBS. Then second, do the computation for the forward pass, which will help you to know the total duration of the project. And then thirdly, you must be able to do the back pass computations, which will help you to do two things: identify the critical path and also identify the total float of the project, which can help you when you can crash a project, as Ada mentioned. So now let's get into the work. So now the first thing to do is to understand the parts of the work package which are going to use to calculate the critical path. By this time, when you say work package, we know what we mean. So the breakdown of the project activity is called the work package. So the work package in this case is supposed to be divided as follows. So as you can see, all right, as you can see, we need to have the ES, all right? We need to have the ES. And then you need to have the task ID, this one here. And you need to have the EF, okay, the task name, and also the LS, the duration, and the LF. So you need to have those items, which will be very, very important to use. All right. So now the ES in this case simply means early start. And then the EF means early finish. We need these two for us to do the forward pass. And then to do the back pass, we need the LS, which means let's start. And we need the LS, which means let's start, and the LF, which means let's finish. These are going to help us complete the loop, and you're going to be able to tell the critical path and also the total float. All right, so let's get started. Let's begin with the forward pass. How do you compute the forward pass? The forward pass is a question of how soon can the activity be started, that is the early start, and how soon an activity can be finished or expected finish. Right. So now the back pass is a question of how late can the activity be started and how late can the activity be finished. In this case, you'll be able to know the critical path and also the total slack of the project after finishing the back pass. All right. So as Ina mentioned, before you do any computations of the critical path, you must be able to come up with the WBS, which we are seeing on the screen here. So the WBS, the work breakdown structure, is supposed to have basically 4 columns to assist you do the computations of the critical path. That is the activity ID, the description, the preceding activities, and also the duration for you to estimate and compute the time which you need for the project. All right. So now, having this, now let's see how we can handle the forward pass. How do you do the forward pass? First of all, you need to know how to do the early finish. The early finish is dependent on the early start plus the duration. If you remember, we divided the work package as follows, okay? The early start and the early finish and the duration. So when you're given the work breakdown structure, the table, you are going to have the early start given, and then you're going to have the duration provided. So these two will be added to find the early finish. That's what this computation we are looking at is about. Okay, so that is the early start plus the duration will give you the early finish. And then if you want to move on to the next work package, the early finish becomes the early start. And then you go back to the same method to find the next early finish of the activity. Now, this is a key point. The next succeeding activity is a merge activity. What does it mean? If the next or the preceding activity comes from the two activities which are linking together, the merging activity. So how do you know which early finish to pick and put it as a start, okay, of the next activity? And this is what we're talking about here. So in this case, the largest early finish, you compare the two. You pick the largest early finish, and that's what you take on the next activity as the early start, and do this same formula until you finish. All right, so all these are the computations which we will demonstrate, okay, on this diagram here. So this diagram basically demonstrate how the forward pass computations are done. Look at this. This table or this network diagram is extracted from the WBS, the one that I showed you. And I need to mention at this point that for you to do the critical path computations or analysis, you must be able to draw a network diagram from the WBS. If you cannot do that, then it will be very difficult for you to do the critical path analysis because it is dependent on the network diagram. So you need to master how to draw the network diagrams. Very, very important. So now, remember the first activity was approval. Okay, if I have to take you back to the WBS, the first activity is apply for approval, and it has the duration of what? 5. And it is a start activity, so it will start with a 0 as the head start. Okay, so that's why it has a 0 because it's first activity and it has a duration of 5. So look at, this is the head start and this is the head finish. So we said for you to compute the head finish, you need to add the head start plus the duration. That's why 0 plus 5, you're getting what? You're getting 5. And you said for you to move on to the next activity, which is the clearing space, and it had 5 duration also. You need to pick this head finish and pass it to the next one. So this 5 automatically becomes the head start of this activity. So for you to find the head finish, you need to add 5 plus 5, and it will give you what? 10. How following? So this is how you do the forward pass. Now here, this is a split. Okay, after this, there's a split activity. There are 2 nodes, okay, which are dependent on this. So when you're splitting, you need to just duplicate the head finish on these splitting activities. All right, so you put 10 here as head start, and you also put 10 here as what? Head start. Now, each of these activities, they've got their own duration. So this one, the digging at 10 days, and the gathering material at 5 days. So both of them are going to inherit 10 as their own head start, like we can see here. So in this case, now we can do the head finish for each activity. So you do 10 plus 10, you get 20. And also here 10 plus 5, you get what? 15. Now this is a point we said when you encounter a merging activity. Remember, we had a split activity where you duplicate. Okay, the head finish becomes head start and also head start. But if you are merging, there it becomes a problem. Why? Because you've got 2 head finish which can be passed to the next merging activity. And you have to just pick one. So do you just guess which one to pick? Remember the law or the rule, okay, guiding that said the next succeeding activity is a merge activity. In this case, the largest head finish of all, its immediate predecessor is selected. So what's the point here? So the point here is that if you have the 2 merging activity, always pick the largest head finish, then it becomes the head start of the merging activity. So in this case, there's 20 and there's 15. Which one is big? Okay, we know 20 is bigger than 15. So that's why 20 has been selected as the head start of this activity, building foundation. Right. So now this building foundation has its own duration. So to get its head finish, 20 plus 15, you get what? 35. So this is just the single node. So automatically 35 is passed here as head start. Again, you do 35 plus 20, you get what? 55. It's a single transition. So 55 comes automatically. 55 plus 5, you get 60. Again, we encounter split. When we encounter split, basically, we just duplicate. So 60 comes here, and also 60 comes here. So just continue. 60 plus 10, 70. 60 plus 5, 65. Now there's a merge. Remember the rule? You pick the biggest head finish, then it becomes the head start. So 70 and 65, 70 is bigger. So that's why you're going to take 70 and pass it here. And you do 70 plus 5, you get what? 75. So as I said, the forward pass, it will help you to know the total duration of the project. So this project will take 75 days to finish. So you don't just scratch your head and say, okay, I'll take 2 months to finish your project. No. For you to give that answer, you must be able to do this process that we have discussed here. And then you can confidently say, I'm going to take these days to finish the project. All right. So this is the forward pass. You can go through it again, watch it over and over, try to master it. Very, very important. Now, the back pass is the opposite. Instead of adding, we'll be subtracting. So as we are going back, we'll be doing last finish minus duration. And the last, okay, the late start is the one that will be passed as the late finish, and you keep on subtracting just like that. Now, when you're going back and then you meet the merge, what is the rule? The rule is opposite from the forward pass, where you pick the biggest. But in this case, we'll be picking the smallest as we go back. So how do we do this? So let me demonstrate all these rules, all these steps from the diagram. Imagine we have reached, okay, remember that we reached here with the forward pass. And this time we want to do the back pass. So you just drop this 75 down here, and it automatically becomes the late finish of this activity. All right. So now you move this activity. All right. Also, we have to do the same. You must be subtracting. You must be subtracting as opposed to adding. So you say the duration is 5. All right. The duration is 5. And what is the late finish? Is 75. So you say 75 minus 5. What do you get? You get 70. Now, a split is same as a split when going forward. So just duplicate this late start on both here. All right. So 70 comes in. Then to find this is 70 minus 5. You get what? 65. Okay. To find this, you do 70 minus 10. That's 60. Now, this is a merge. Remember, if you're going backwards, you go for the smallest as opposed to the biggest. So if you compare 60 and 65, 60 is the smallest. That's how come it has come here. All right. So you keep on. So 60 minus 5 is 55. All right. So it's a single move. So just duplicate 55 here. So again, 55 minus 20, you get 35. If you're going backwards, you'll be subtracting as opposed to adding when you're going forward. So 35 is a single movement. So you just move 35 here. So the 35 minus 15, you get 20. You encounter a split. Same procedure, same rule. If you're going backwards or forward, you encounter a split, just duplicate. So 20 comes here and also 20 comes there. So keep on subtracting. 20 minus 5, you get 15. 20 minus 10, you get 10. You encounter a merge. A merge, if you're going backwards, go for the smallest number. So between 10 and 15, what's the smallest number? Is 10. So it's the one that you put here. So 10 minus 5, 5. All right. It's a single movement. So just duplicate 5 there, just like that. 5 minus 5, 0. This is correct. When you're going backwards and you encounter the same number here and here is the same, you are correct. So this is a complete critical path analysis of this network diagram. So now, how will this help us to know the float and the critical path? We said as you're going back, you are going to know two things. You know the critical path and you know the total float. Since the forward pass, we have established that the forward pass will help you to know the what? The total duration, which is 75. Now, going backwards, let's do two things. So now, let's begin with the critical path. Critical path is the path with activities without float. Okay, for you to understand it very well, you have to use that definition. So we're going to be picking the activities that have no float. And how do you tell the float of a particular activity? How do you tell the float? It's very simple, people. The float of any particular activity is basically you subtract the edit finish and also the rate finish, or the edit start and also the rate start. So you can do that to basically able to know the float. So if you look at this one, the first one, 5 minus 5 is 0. This activity has no float. So it's critical. So to be part of the critical path. Let's move on. 10 minus 10 is 0. So this activity has no float, no free time. So to be part of the critical path. All right. What about this one? 20 minus 20 is 0. So this will be part of the critical path. What about this one? 20 minus 15, 5. So this one has a float of 5. So this is not critical. So it has some bit of delay. What about this one? 35 minus 35 is 0. It's part of critical. So this activity is critical. What about this one? 55 minus 55, this activity is critical. 60 minus 60 is 0. This activity is critical. What about this one? 70 minus 70 is 0. So this activity is critical. There's no free time. What about this one? 70 minus 65 is 5. So there's 5 days free here. There's a float of 5. All right. So this is not critical. 75 minus 75 is 0. So this activity is critical. So if you followed, the critical path is going to include A, B, C, E, F, G, H, and J. Why? Because these activities, they don't have the float. So you can say the critical path, it is basically this path here. So as you move along this path of a project, never delay anything. Otherwise, the project will be delayed. So the non-critical path is this path, where there's 5 days free here, and there's 5 days free here. So this path is non-critical because of these two activities with 5 days here and 5 days here. So to know the total free days of the project, add the floats for each activity. So there was 5 days here, and there was 5 days here. So you add 5 plus 5, you get 10. So this activity has a total float of 10 days. So which means if you are to crash the project, you can do it within 10 days. Pick a day within 10 days to deliver the project before the deadline. That's what to call project crashing. So sometimes the customer will come to you, okay, if possible, I would like you to deliver the project 2 days before, or even better, 5 days before the date that we estimated. So there, you don't just say, yes, it can be done. You first of all, go through these computations and agree with the customer. Yes, 2 days is possible. We can deliver it within 2 days. Or before 5 days, we can deliver it. Or if you know that you've got 10 days to impress your customer, you can even deliver it 8 days before, and the customer will be very happy with you because you have done the best in time. That is what you call beating the expectations of the users. So this is very critical as a project manager. You need to have this skill. This is a skill that differentiates you from other project team members, because you'll be able to plan your project and deliver it in time. The worst case scenario is on time, as opposed to late submission of the project or delivery of the project. That is not recommended. So people, I would like you to go through this, master it. You can do any project planning with this skill that I've given you today. All right, so this part shows what I've just demonstrated, how to do the float by subtracting the rate start from the edit finish. All right. So you can try, okay, to revise this lesson by answering this question here. Okay, this question shows the work breakdown structure, which can help you to come up with a network diagram and calculate the critical path, and also able to tell the float, the total float of the project. Well, this is how far you can go. I'll encourage you to watch the video again, practice, 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 practice. Then these points will become part of you. And this will help you to become a good project manager. Thanks very much.